For most of the 20th century, dinosaurs were seen as failures. In museums and school books, they were portrayed as slow, stupid, and doomed great beasts too lazy to survive. The textbooks called them nature's mistakes, relics of a forgotten age. In movies from the 1950s, they lumbered through stop-motion deserts, dragging their tails, roaring mindlessly to the public. Dinosaurs were little more than monsters, fascinating, but primitive. Even scientists described them as cold-blooded reptiles who grew too large for their own good. But the fossils told a different story. Their bones carried hidden clues, hollow spaces, fine muscle attachments, signs of motion and heat. It just took the right people to listen. And in the 1960s, two men, John Ostrom and his student Robert Bakker, would challenge everything the world thought it knew about dinosaurs. They would ignite what became known as the Dinosaur Renaissance, a scientific revolution that brought the giants back to life. For nearly 70 years after the Bone Wars, paleontology had gone quiet. By the early 1900s, most great fossil sites had been stripped bare, and museums were full. Researchers cataloged bones like relics, not clues. To them, dinosaurs were evolutionary dead ends, slow, lumbering creatures that simply couldn't compete. During World War II and the Cold War years, funding dried up. Few young scientists entered paleontology. A handful of aging researchers kept the field alive, repeating old ideas first written in the 1800s. They believed dinosaurs were overgrown reptiles, cold-blooded, swamp-dwelling creatures that dragged themselves through life until they finally perished. It was a quiet age, a time when dinosaurs were seen as the past, not as living, breathing parts of the evolutionary story. But in the mid-1960s, a new generation of scientists began to question that stillness. One of them was John Ostrom, a Yale paleontologist who looked at bones and saw not sloth, but motion. In 1964, Ostrom led a field expedition to the dusty plains of Montana. There, half buried in red sandstone, his team uncovered the bones of a creature unlike anything they had ever seen. It had long legs, a stiff tail, a deep chest, and curved claws built for slashing. Ostrom named it Deinonychus antiropus, terrible claw, counterbalance. The fossil didn't match the old image of a sluggish reptile. It looked agile, balanced, predatory. Ostrom studied the limbs and realized this animal ran on two legs, using its stiff tail for stability like a cheetah's counterweight. This, he wrote, was no lumbering lizard. This was a fast, warm creature, an athlete of its world. Deinonychus wasn't just a new dinosaur. It was a revelation. It forced scientists to imagine movement, energy, and strategy qualities they never thought dinosaurs possessed. And behind Ostrom's microscope stood a young student ready to carry that revolution even further. Robert Bakker. Robert Bakker was everything science wasn't supposed to be. In the 1960s, loud, passionate, defiant. He had studied under Ostrom, but saw more than just anatomy. He saw life, motion, and behavior. In his sketches, Deinonychus leaped mid-air, feathers flying, claws extended, an animal alive with purpose. He rejected the idea of cold, swamp-bound monsters and began preaching a radical idea: dinosaurs were warm-blooded. In the 1970s, his lectures shocked traditionalists. Bakker claimed that dinosaurs were fast, intelligent, and socially complex, not mistakes of evolution, but its masterpiece. His 1986 book, The Dinosaur Heresies, turned that heresy into a movement. The scientific community mocked him at first. Colleagues dismissed his warm-blooded theory as fantasy, but Bakker didn't back down. He traveled across America, painting vivid murals and giving talks that inspired a generation of young paleontologists. Slowly, his vision began to take hold, not just in classrooms, but in the hearts of everyone who had ever dreamed of dinosaurs alive again. Bakker's boldest claim was simple: dinosaurs weren't cold-blooded reptiles. They were endothermic, warm-blooded, like birds and mammals. That meant they could move faster, live in colder climates, and sustain high energy for long hunts. The evidence began to pile up. Cross-sections of bone revealed dense blood vessel networks, signs of rapid growth. The microscopic structure resembled that of modern mammals, not reptiles. Some species even showed annual growth rings like trees, proving they grew quickly year-round, not just in bursts of summer heat. Fossil trackways told the same story: herds moving in unison, predators running in packs, speeds no cold-blooded animal could maintain. Even the tail vertebrae of Deinonychus suggested powerful muscles for balance, the mark of an active runner. To Bakker and Ostrom, these clues were more than data. They were proof that dinosaurs weren't extinct in spirit. They were the ancestors of life's greatest survivors. The Renaissance had begun, and the old world of sluggish monsters was fading fast. But there was one question left: where did the dinosaurs truly go? The answer was older than anyone realized. In 1861, a strange fossil was discovered in a German quarry, a small creature with feathers, claws, and teeth. It was named Archaeopteryx. For decades, scientists argued whether it was a bird or a dinosaur. Ostrom returned to it with fresh eyes. Comparing Archaeopteryx to Deinonychus, he noticed identical features: the backward-pointing pelvis, the clawed hands, the wishbone. To him, the evidence was undeniable. Birds weren't just relatives of dinosaurs, they were dinosaurs. The idea was radical. It shattered the long-held divide between reptiles and birds. Critics laughed, calling it science fiction. But as more fossils appeared, the laughter faded. By the 1980s, even conservative paleontologists began to admit the truth. Dinosaurs hadn't died out. They had simply taken flight. Then, in 1996, everything changed again. In the Liaoning province of China, farmers uncovered fossils that glimmered with fine, feathery impressions. The first was Sinosauropteryx, a small theropod covered in hair-like filaments. Soon came Caudipteryx, Microraptor, Utyrannus, each one a bridge between reptile and bird. The world had never seen anything like it. For the first time, we could see evolution feathers, not imagined, but real, fossilized in stone. Scientists realized feathers weren't just for flight, somewhat. They were for warmth, for display, for survival. Color patterns began to emerge: black stripes, red crests revealing the first hints of dinosaur color. The discovery rewrote textbooks and museum displays. It turned the reptile age into a vibrant ecosystem of life, sound, and motion. The Renaissance had gone global, from Montana to China, from bones to feathers, from death to life. In 1993, everything the scientists dreamed finally came to life on screen. Jurassic Park exploded into theaters, showing dinosaurs not as sluggish monsters, but as alert, intelligent, and terrifyingly alive. Director Steven Spielberg based his creatures on the new science, on Bakker's sketches and Ostrom's research. Deinonychus became the iconic velociraptor. They hunted in packs, communicated, coordinated traits no one imagined a decade earlier. The film sparked a global obsession. Kids memorized dinosaur names, adults revisited museum halls. Fossil digs saw record volunteer numbers. Paleontology was cool again. Behind the spectacle was something deeper, a scientific vindication. Bakker and Ostrom's once radical vision had become mainstream. The dinosaurs had been reborn not through cloning, but through imagination and science united. The revolution didn't stop in the 1990s. Today, paleontology stands at the crossroads of biology, chemistry, and technology. 3D scanning lets scientists reconstruct muscles and motion. CT imaging peers inside fossilized skulls, revealing brain structures once thought lost. Chemical analysis detects pigments showing that Anchiornis had black and white feathers with a red crest. In 2005, paleontologist Mary Schweitzer made one of the most shocking discoveries in modern science: soft tissue inside a T. rex femur, flexible blood vessels, and what appeared to be red blood cells. It was the first tangible link between ancient and modern biology. Geneticists began comparing bird DNA with fossil proteins, finding echoes millions of years apart. The dream of the Dinosaur Renaissance, to see these creatures as living beings, not relics, had become real. We could now measure their heartbeat, estimate their color, even model their movement frame by frame. The giants had truly come back to life, more than half a century after it began. The Dinosaur Renaissance still shapes how we see life itself. It wasn't just about dinosaurs. It was about rediscovering the energy of evolution, the truth that nature never stands still. The old view saw extinction as an ending. The Renaissance proved it was transformation. Birds still soar with the bones of their ancestors. Every heartbeat in a robin carries the rhythm of a Deinonychus. Walk into any modern museum today, and you won't find cold statues in swamps. You'll find predators in motion, feathers shining, eyes alive with intent. Children stare up, not at monsters, but at survivors. That's the legacy of Ostrom and Bakker. They didn't bring dinosaurs back with DNA or machines. They brought them back with truth. They changed how humanity imagines life, not as a ladder, but as a circle that never stops turning. The bones never changed. Only our eyes did. We didn't resurrect the dinosaurs. We remembered them. Remembered